Alice and Bob share 1 over root 2, 0, 0, plus 1, 1. Fact, if Alice and Bob make measurement of form alpha 0 plus beta 1. What? No, that's not what I wanted. Alpha 0 plus sigma x and sigma z. So they both make the same measurement, which is on, well, on this this great circle of the Bloch sphere. They get the same outcome. So, and if they measure with the observable sigma y, they get opposite outcomes. So we won't, I'm not going to, I mean, you can easily check that. Proof for alpha equals 0 and alpha equals 1. And here I probably should have said alpha squared plus beta squared. It's 1 alpha beta real. I'm not sure it matters if alpha beta are real, but yeah, alpha beta are real, yeah. Otherwise, this is not Hermitian, so it's not an observable. So proof for alpha equals 0 and alpha equals 1. Alpha equals 1, that's sigma z, and they're just measuring in the 0, 1 basis, which means 0, you know, they either get both 0 or they both get 1. No, wait, that's alpha equals 0 is easy. Alpha equals 1. That's 1 over root 2 alpha, no, 0, 1, 0, 0 plus 1, 1. And I'm going to put another 1 over root 2 here. So this is, say, Alice's state. And this is Alice Bob, Alice Bob. When we multiply this by this, we get 0 Bob. And we multiply this by this, we get 0 1 Bob. And there's a 1/2 in front of here. And similarly, if we had a minus here and a plus here, we would get a minus there. So when we take the projection onto 0 plus 1, we get 0 plus 1. When we take the projection onto 0 minus 1, we get 0 minus 1. And in fact, and the proof for arbitrary alpha is not so hard. I'm not going to go through it right now for, you know, for lack of time. But I want to use this. So this was what we want. And I'm going to erase 75%, but hopefully you guys can remember that. and say what is our strategy? Well, 0, 1. No, wait. I'm trying to draw a piece of the block sphere. So 0, 1, plus, minus, and these are the points that are 45 degrees. So this is the slice, vertical slice through the block sphere. So Alice chooses 0, 1, or plus, minus. So Alice and Bob are going to measure, each going to measure their half of the state. And I want to say Alice chooses 0, 1, or plus, minus with probability 50%. And Bob chooses, no, not with probability 50%, depending on what bit A was. So A equals 0 and A equals 1. And Bob chooses, we need variables. So let's call this S and this axis T. So Bob chooses S, and the opposite of S, if A equals 0, if B equals 0, and he chooses T and opposite state of T if B equals 1.